Hello everyone, myself Tejasvi and my teammate Mahita from team number 8B. I'm very delighted and it's a pleasure to explain about our project idea and its implementation. As you can see, the main aim of our project is an efficient novel approach for prediction of startup company success rate through machine learning paradigms. It's a prediction analysis model using machine learning paradigms. Moving on to the abstract, this project holds significant value for investors and business people as it provides them with valuable insights and decision making support in the startup ecosystem. Investing in startup involves inherent risk. By utilizing the predictive model developed in this project, investors can access the potential for success of startup ventures more accurately. By leveraging the predictive model, investors can identify startups with a higher likelihood of success, allowing them to allocate their resources more strategically. Business people, on the other hand, can utilize the model to evaluate potential partnerships or collaborations with startups. Further, let's have a look at the existing system features. The existing system has several limitations that affect the prediction process. Firstly, the system did not remove unwanted or irrelevant data, leading to the inclusion of unnecessary variables that could hinder accurate predictions. Additionally, the system only considered a few parameters such as initial and final funding, which may not capture the full complexity of startup success prediction. Another drawback is that the existing system directly started analyzing the data without performing pre-processing steps. This means that outliers and erroneous data were not properly handled, which can negatively impact the accuracy of the predictions. Without addressing these issues, the system predictions may be less reliable and less useful for decision making. Now, moving on further, considering the disadvantages of the existing system, we have proposed our system to overcome them. The proposed system introduces several advancements to overcome the limitations of the existing system. Firstly, we have implemented efficient data processing techniques in Python to remove unnecessary data and manipulate the remaining data. This enhances the reliability of the system and enables better decision making for investors and business people. One notable feature in our proposed system is the creation of a web page that allows users to interact with the system. This web page provides a user friendly interface where users can input their data and receive predictions for startup success. By using few requirements, we have developed our model. The software and hardware requirements are the software requirements for the project include a Jupyter notebook, environment, Python programming language, and relevant machine learning libraries and frameworks such as scikit-learn, pandas, and NumPy. Additionally, the project utilizes Flask, a web framework for Python, to develop the interactive web page. These software and hardware requirements will ensure that the project runs smoothly and efficiently, allowing for accurate predictions and seamless user experience. Now, moving on to the literature part, we have gone through few IEEE papers to gather existing knowledge and research related to the project topic. Going through all these papers gave us a deeper understanding of the subject matter and enhanced the quality and credibility of our project work. Now, let's get on to the technology used. In our project, we have leveraged the power of machine learning using popular technologies and frameworks. We utilize Python programming language for its extensive libraries and frameworks such as scikit-learn and pandas, which provide robust tools for data manipulation and model development. Additionally, we employed Flask, a micro web framework in Python, to create an interactive web page for user interaction with the machine learning model. Now further, moving on to the design part, use case, we have used three UML diagrams. The first one is use case diagram. Use case diagram consists of actor and use cases and the relationship. Actor has the access to the user interface only. It only gives input and further development is done by the developer and output is viewed by the actor. The next UML diagram we used is a sequence diagram. Sequence diagram represents a flow of diagram. The other diagram, the other UML diagram we used is a class diagram. Class diagram gives the static view of the system. It not only used for visualizing or describing, but also used for constructing executable code of software application. It is a visual representation of information flows within a system. It is a model that conceptually. Next, moving on to the data flow diagram. This is the visual representation of the information within a system. It is a model that conceptually which gives us the flow of which gives the information flow within a system. Now moving on to the system architecture, it is a model that conceptually defines the views, structure, and visual representation of the system. Let us now have a look at the implementation part. The very first process in implementation part is data collection processing. The first step involved collecting the relevant data for startup companies, including financial information, market trends, and team dynamics. The data was then pre-processed to remove any inconsistencies, outliers, or missing values. The further step after collecting the data is feature selection engineering. Once the data was pre-processed, the next step was to select the most relevant features from predicting startup success. This involved analyzing the correlation between different variables and selecting the ones that had the highest impact on the target variable. Let us have a look at our code implementation part. We have used in the we have done it in the Jupyter notebook using Python. In the very first part, we have imported all the necessary libraries. We have read the data. We have split the data set into training and testing part. We used a few features to get to know. We have brought few data sets from the data set. We have used a drop function to remove unwanted data from the data set. We have split the data into training set and testing set. Uh, this is the visual representation of the target variable. Now, by using by using the algorithms, we have used five algorithms. Random forest classifier, this is the execution of the random forest classifier. We have brought the performance metrics of the random forest classifier, that is precision, accuracy, recall, f1 score, and confusion matrix. And next algorithm we have used is logistic regression. We have even got the performance metrics. And next one is support vector machine, the performance metrics of the support vector machine, and the Gaussian naive Bayes, the performance metrics of the Gaussian Bayes, and k nearest neighbor, the last algorithm which we have used. By considering all the algorithms we have used, the accuracy of the accuracy of the accuracy of the support vector machine was high. The performance of each model were accessed using metrics such as accuracy, precision, recall, and F1 score. The models were fine-tuned by adjusting hyperparameters to optimize their performance. Next, we have used a pickle file in Python. This is used for serializing objects, which means converting the objects into a byte stream that can be stored or transmitted. In this case, the trained random forest model is being serialized and saved into file using pickle dump function. The predict.pkl used here. This file can be later used to load the trained model and make predictions without the need for retraining. The use of pickle file in connecting a Jupyter notebook and a Flask application is used to store the data is used to store the trained machine learning model in a serialized format. This allows the model to be easily loaded and used with the Flask application without the need of retraining. We have connected our machine learning algorithm with the Flask using pickle file. This is the code implementation of the Flask. Finally, a web application was built. After executing this code, we have brought the web application was built. Finally, a web application was built using Flask, allowing users to interact with the training model. The application provides a user-friendly interface where users can put the relevant information about a startup and obtain a prediction of its likelihood of a success. Let us give us few inputs: the relationships, funding rounds, funding total USD, milestones, and the average participants involved in the startup. Now, by clicking on the predict, we get the prediction. We get the prediction. Our prediction says that our startup might fail as milestones are less. Basing on the attributes we have used, like relationship, funding rounds, funding total USD, milestone, and average predictions, our project would give a proper suggestion whether investing in this particular project is would lead to success or would definitely lead to failure. So by giving this measurements and attribute values, we get the prediction.
We'll see about the success.
We will see about the success rate. We have given relationships as 5, funding rounds as 5, funding total USD as
1 lakh.
1 lakh, milestones, average participants. Now, by giving all these attribute values, our prediction says that your startup will hopefully be a success. This is the implementation part of our project. Then, moving on further to the results. But in conclusion, our project successfully addressed the challenge of determining the success potential of startup using machine learning. We have linked the machine learning algorithms, the Python, the server-side programming to the front end using Flask application. This is a very greatly benefit investors. It would definitely be a project which is very much useful for the investors, allowing allowing them to allocate the resources more strategically. Business people also, on the other hand, can utilize the model to evaluate potential partnerships or collaboration with the startup. The future scope, we have just in our project we have our model just predicted yes or no, that is whether it gives profit or loss. But in the future we can even predict at what range the success would be possible. The percentage range, how much the investors can invest in the startups. Let's meet our team. We thank our project guide, Mrs. Bharati ma'am, for giving us constant support, and my team member Mahita for being a best teammate and supporting in all the progress of the project. I think it wouldn't be successful without her. Thank you. Thank you, everyone.